Hello, we are going to talk about binomial probability distributions today. I believe this is chapter 5 in your book, but let's start out and just talk about the word binomial. Bi is a prefix that means two. Nomial sounds like number, numeral, something. So we're looking at distributions for probability where there are two outcomes, like you have a boy or a girl. You flip a head or a tail. You get your free throw or you miss it. You get a hit or you don't. It's going to rain or it's not. But it's not anything that has more than one outcome. Like you can't say, I'm going to roll a die and record all the different numbers that I've got, because the probability has there's 6 different choices and we only need 2. So 2 outcomes, and our outcomes are called success and failure. So if you're having children, it might be boy is success, girl is failure. It could be girl is success, boy is failure. It's sort of arbitrary. Just whatever you're looking for is called success, and it is P. And failure is the opposite of that. It's just 1 minus P. And sometimes people use Q for failure. There are a fixed number of trials. Number will represent with N, and it's like you're going to shoot 10 free throws. You're going to roll 5, or you're going to flip 5 coins. You're going to have 3 children. But it's not like I'm going to shoot free throws until I get one. So it doesn't quite work like that. The probability of success doesn't change. So if you are shooting free throws and you're a 70% free throw shooter, then your first probability is 70%, and your next one, and your next one, and your next one. It doesn't change, and you say, suddenly I am due a free throw, or I am due to miss. The trials are independent, so shooting one free throw doesn't have anything to do with the next one. Having a boy the first time doesn't change the probability that you'll have a boy the next time. It's still 50% each time. And if you add all the probabilities together, they'll add up to 1. Just like flipping a coin. Heads is 1/2, tails is 1/2. So that adds up to 1. Okay. Or if you're using decimals, sometimes it's very, very close to 1. Okay, so I made a little chart here. Suppose we're going to have 3 children. We haven't had any children yet, but this family wants to have 3 children. They could have a boy, boy, boy. They could have 2 boys and then a girl. They could have a boy and then a girl and then a boy, and so on. Or they could have all 3 girls. And so I made a table for the number of boys. The probability of no boys is 1/8, 0.125. Exactly 1 boy, the probability is 3/8, or 0.375, and so on. And you'll notice if you add all that together, those probabilities add up to exactly 1. So just using the table, the probability of 2 boys then would be 0.375. 2 or more boys, we'll add those together, and that adds up to 0.5. All boys is right here, 0.125, and at least 1 girl. Now, for at least 1 girl, we could add all of those together, but we know that at least 1 girl is the only thing that can happen if you have at least 1 boy. So 1 minus the probability of okay, didn't really mean that. At least 1 girl. The only way that you don't have at least 1 girl is if you have all boys. I knew I had these there for a reason. And all boys is 0.125. So we could just subtract that. Then is that 0.875? Okay. But that brings me to the next thing. We need to talk about vocabulary. translating English to math, and I think English is way harder than math, but you need to be able to do this so that you know what you're trying to find in your calculator. So if we had 8 men and 40% have brown eyes, just 5 means exactly that. Just 5. It may say just 5, only 5. It may just say 5, but you'll recognize it as just one number. Less than 5. All of these have a 5 in them, but less than 5 only goes up through 4. At least 5 would start at 5, 5, 6, 7, 8. That's how dancers count. 5, 6, 7, 8. Okay, more than 5. We don't include the 5, so more than 5 is 6, 7, 8. And at most 5 does include the 5. So they're all different, and we need to be able to translate from English into math, and that is what we're going to talk about next. Okay, so now you need a calculator. And I will pull mine up over here. Oops, did not mean to do that. Okay, so in your calculator, we have 2 different things that we're going to work on. A binomial PDF and a binomial CDF. I'm trying to get everything on the screen here. I don't know how to get me off the screen. Okay, well, here we go. Go to second distributions, and you'll have normals, inverse normals, you'll have all kinds of things. But the bottom 2 things are binomial PDF and binomial CDF. PDF is the probability of one particular value, one exact value, like just 5. One particular thing. P for particular thing. Binomial CDF is used to find cumulative probabilities. So let's do a couple of problems. Okay. We have 8 men and 40% of them have brown eyes. What is the probability that exactly 5 have brown eyes? Okay, so binomial PDF, and it may ask you for your trials and your p-value and x. So we have 8 men. Our probability is 40%, and we are looking for 5. And this may say enter, it may say paste. And if you don't have this, you'll put it in with commas. Binomial PDF 8, comma, 0.4, comma, 5, and it will look like this. Okay. You should find your probability to be 0.1238 something, and we round probabilities to 3 significant digits, so we'll go with 0.124. At most 5. Okay, and you always write down what you want. At most 5, 0, 1, 2, 3, 4, 5. It includes 0. It is cumulative, so we're going to do second distribution and go down to binomial CDF. We still have 8 men. 40% still have brown eyes, and this will count the probability of no men plus 1 plus 2 plus 3 plus 4 plus 5. 0.950. Okay, last one. More than 5. More than 5 is 6, 7, 8. And you go, dang, I don't even have a 0. I can't do binomial CDF cumulative because I have a 0. So if we want 6, 7, and 8, you need to find the probability of the complement and subtract that from 1. So we're going to do 1 minus, I'm going to abbreviate this, binomial CDF, 8 min, 0.4, and our top number now is 5. And we know what that's going to be, but I'm going to do the whole thing anyway. 1 minus second distribution, this is a CDF, so I have 1 minus that, which is 0.0498 or 0.050. Which is the opposite of that. We just found the complement. So, in the immortal words of the Rolling Stones, you can't always get what you want. You get what you need. And you need a 0. Okay, hope this is helpful. And as always, let me know if I can help in any way.